All right, ready for 1.5a. I am assuming, looking at this chapter, that it's going to be a little bit long. So we'll start with the 1.5a, thinking we'll end up with a 1.5b eventually. The name of this section is Polynomials, Sums, Differences, and Products. First of all, you've got a polynomial, which has as its prefix the word poly, which means many. And so pretty much what a polynomial is an expression with many terms. So a term, or what is called a monomial. Mono means one. So a polynomial is made up of many monomials or many terms. And a term is, for the most part, a constant. A constant is just a number, or the product of a constant and one or more variables, or if I have more variables or more. Those are all like term, or that's a term. Okay? So usually terms are separated by a plus or a minus sign. So we have two terms here because we have one plus sign. And a lot of people will just count the plus and minus signs, add one, and find out how many terms they have. But there's really not much reason that you need to know how many terms you have. You just have to know what terms are, and that a polynomial is a bunch of like terms strung together with plus or minus signs. So if you look in the middle of page 57 where it says the following are polynomials, there are three different examples there separated by plus or minus signs. So it's really easy to count, like in the first one, 2x squared minus 6x plus 3. There are three terms. And when you have three terms, or let's just say when you have two terms, like what I have right there, those are called binomials. Comes from the letter or the phrase bi, like bicycle, meaning two. And if we have three terms, it's called a trinomial. So those of you that have had a little bit of math know these terms already. So probably not too difficult for you to remember. And they're not those kind of things, don't tell anybody, but they're not those kind of things that you're going to use a ton. So the next thing we've got in the definitions, middle of page 57, is a degree. A degree of a polynomial is, let me write this one here first. The degree of a polynomial is the highest power to which the variable is raised in any one term. So we look at the three terms we have there. We look at the variable with an exponent, and we see that the 2 is the biggest one. So that has a degree of 2. A couple other things when you're looking here. Normally when you have one variable, you go in decreasing powers. So we started with a 2 here, and then the x has a 1, and then there are no x's on the 1 here. So we went 2, 1, 0 x's. So this is called decreasing order, and that's normally the way that you write polynomials, especially when you're using it in an answer. The coefficient is any number in front of a variable. So the 6 is a coefficient, the 2 is a coefficient of x, and then you've got a final definition called a leading coefficient, which is the first term, the coefficient of the first term. So it leads, it's the first one. So just some basic vocabulary there. Now we're going to get into like terms here, or similar terms. Now I have a little bit different definition of a term than what the book says, but I think it's an easy definition to remember, and it is correct. So for instance, if I have 4x squared plus 3x plus 4 plus 2x squared. All right, so if I'm looking for like terms, what I do is I look for all the variables. So I have a variable there, there, and there. I look at the exponents on the variable. There's a 2 there. There is an assumed 1 there. And there's a 2 up there. So when I look at each one of these terms, I look at the variables. I have to have the exact same letters, the same variables, with the exact exponents. So because I have an x squared here and an x squared there, I can combine these two terms, and I'm going to put the plus sign with them, and I can add those up, and 4 plus 2 is 6, x squared. So when you're adding, you only add the coefficients, the numbers in front of the variables. You do not do anything with the exponents. And then I write the rest as it is because there isn't anything else that is a like term. So that's my definition of like terms. So let's go ahead and look at the example they give. Example 6, minus 4x plus 2. And they want to add 3x squared plus 9x minus 6. Now I like to put boxes or squares or circles or something around like terms. It just helps me, and with me having different colors I can do this. So I have an x squared and I have an x squared. I have a negative 4x and I have a plus 9x. And finally, I have a plus 2 and a minus 6. All right, let's look at each one of these individually. X squared and x squared, same variable, same exponent. I can combine those. The green, I have an x and I have an x, same variable, same exponent. The 2 here is a constant, no variable. The negative 6 is a constant, no variable, so I can combine those. So let's go ahead and combine the blues. I get 8x squared, and let's combine the green. I'm adding negative 4x to 9x. The signs are different, so I take the difference of the two and I put the sign of the largest number here, and then I add my constants. 2 plus negative 6, take the difference of the two, put the sign of the largest on there. So 2 plus negative 6, and that's where I got the negative 4. So that ends up being not necessarily the answer, but the simplification of that. All right, so, which I guess you could call it an answer, but it's not an equation, so you're not solving for the variable or anything. Okay, so let's look at another one. Example 7. I need black. Negative 8 x cubed plus 7x squared minus 6x plus 5. And they are adding. It says find the sum. The sum is an answer to an addition problem. So we're going to add this other group. 10x cubed plus 3x squared minus 2x minus 6. All right, so some people do it a couple different ways. Some people rewrite the whole thing and put all of the like terms together. So they'll put this one, because it's got an x cubed, and they'll put that one together, and then this one here has an x squared, this one has an x squared, etc. Some people would rather just go across and add as they go. I'm going to put them with like groups here just because it kind of keeps you from making mistakes. And then I cross out as I write it down, because sometimes you get a whole big list and you don't remember what you've used and what you haven't. Plus 3x squared. This takes a little bit of time, but time is good to take if it's going to keep you from making a mistake. Plus 5 minus 6. All right, so now I can combine the terms that are close. So I have a negative 8 plus 10. The signs are different. Take the difference between the two and the sign of the biggest number. Okay, now I'm going to do this one here. The signs are the same, so I just add. And those are done. Now I've got negative 6x minus 2x, or plus negative 2x. So signs are the same, so I just add them up, and I get 8x. And because there's negatives, I get the negative 8x. 5 minus 6 or 5 plus negative 6, signs are different. Take the difference between the two, sign of the largest number on there. And I'm done. So some of you may have faster ways to do it. And again, my rule is as long as you're following mathematical procedures, you can do it many different ways in order to solve. Okay, so this truth is at the bottom of page 58, subtracting polynomials. What that's saying is, if you have a negative in front of a parentheses, you are pretty much, this is like having a 1 here. And what that means is you are taking this negative 1 times a and getting negative a, and you're taking this negative 1 times b and getting negative b, and this plus sign stays right here. All right, so that's important when you're talking about subtracting polynomials. So let me give another example here. If we have a negative, and inside the parenthesis we have 3x plus 4. If we distribute that negative, we get negative times 3x, negative, plus negative times 4. And if you want, you might find it better to write this as negative 3x minus 4. So you can get rid of the plus sign and just have the minus 4 like that. If we were to have negative x squared plus 7x minus 3, let's distribute that negative again. Negative times a negative is a positive x squared. A negative times 7x, and a negative times a negative 3 is plus 3. Now notice what happened here. Let me get rid of some of these arrows and stuff that kind of make everything a little confusing here. And let's look at something here. Now, this is a truth, but I wanted to explain that this is actually, whoops, wrong button, negative 1, and we're distributing that. Notice that whenever we multiply a negative times something in parentheses, it basically changes everything to its opposite, which is what we got here. So it's really quick and easy when you have a set of terms here with a negative here. So if you've got 3x squared plus 2x minus 4, that equals, we just change all the signs, 3x squared minus 2x plus 4. So what we did is we just distributed it. So what this is saying, take the opposite of every sign inside the parenthesis. And that makes it easier for me. So if I have, like example 8 says, subtract 4x squared plus 2x minus 3 from 9x squared minus 3x plus 5. So it says subtract 4x squared plus 2x minus 3. Now there's two things I want you to look at. First, just because the 4x squared plus 2x minus 3 comes first in the instructions, it says subtract that from that. So that means we've got a minus. So the way I have this written here, all I'm subtracting from 9x squared minus 3x plus 5 is the minus 4x squared. I don't have this written correctly. I need to put everything I'm subtracting from there, because what happens is that minus is going to distribute and change everything. So let me write this. This will never change, but this will change to negative 4x squared minus 2x plus 3. So the minus is on the whole part that we're taking away, not just the 4x squared. So now we can start combining like terms. So these two, 9x squared minus 4x squared is 5x squared. negative 3x minus 2x, or plus negative 2x. So minus 3x plus negative 2x is negative 5x. And then we've got a plus 5 and a plus 3 plus 8. So that's our answer for that example 8. So let's jump to example 9. You know, they get more and more challenging as we go. So example 9 is 4x minus 3. We're going to put in braces there, or brackets, 2 minus the quantity, 3x plus 4, end bracket. All right, so notice what we have here. We have a bracket, and then we have parentheses. So when you're doing PEMDAS, you always do the innermost parentheses first and work your way out, and then you leave the brackets, parentheses, afterwards. They're grouping symbols is what they are. So if we look in here, can I do anything with 3x plus 4? I cannot. So then I leave the parentheses and I have the minus sign here. So let's see what we've got. We're going to leave the 4x minus 3 alone. We're going to put our brace here, and then we have 2, and then we have a minus 3x plus 4. So remember, that is like a minus 1, so we're going to distribute that here and here. Minus 3x minus 4. Now I can look in here and see if I have any like terms. So what I'm not doing, I'm just going to leave alone for right now. So 2 minus 4, or plus negative 4, take the difference between the two, sign of the biggest one. So we're done with that, and we're done with that, and we're left with minus 3x. Now we can distribute my negative 3 this way and this way. So we have 4x, negative 3 times negative 2 is positive 6. Negative 3 times negative 3x is positive 9x. I add this one and this one since they're like terms, and I end up with that for an answer. So this looks like a good place to stop with 1.5a, and we'll just spend a few minutes going over 1.5b.